Alright, hello there. I just noticed that the June 2025 exam was just released on the New York State Regents website. So let's see how the test was this time around. I don't know, because there's another one in August. So anyways, which sequence of historic developments led to the modern model of the atom? Okay. Electron shell outside a nucleus. Hard sphere was the first one. Okay. So yeah, hard sphere was the first one. And then electrons outside of nucleus, mostly empty space. I think mostly empty space was before. So I think it's 4 for this one. And then which statement compares the energy of an electron in the third shell to a different shell in the same atom? So electron in the third shell has, that's not true. One electron, this is the nucleus. Then electron shells. The farther away, more energy, because it's feeling less of an attraction to the nucleus, which is positively charged, right? So let's read the options again. An electron in the third shell has less energy than first shell. That's also not true. It would have more. Third shell has more energy than electron in the first shell. This is correct. It has more energy than an electron in the first shell. When an electron and an atom returns from a higher energy state, it emits. Yeah. Okay. So this is like the excitation thing. When an electron, when it absorbs light, it goes to like a higher energy level. And then when it goes back down to its ground state, it emits a unique spectra. And the spectra is like a distinguishing thing between like different elements, because every element has its own unique bright line spectra, right? So this one will be number 3. Atomic mass of chlorine is the weighted average of the atomic masses of naturally occurring isotopes. So the atomic mass is basically the combination of different isotopes you have of chlorine. So the formula to calculating it is the mass of the isotope. So say like, I think it's 35 and 37 for chlorine. So it would be 35, and then the abundance in decimal. And then plus the mass of the other isotope. I think it's 37, I'm not really sure though. And then abundance in decimal. And then the sum of these two would be your atomic mass. Oh wait, did I answer the question? Yeah, 2. The elements on the periodic table are arranged in order of increasing atomic number, because like, for example, if you I don't know, find an example. Argon weighs less than potassium, but argon is before potassium. Weighs more. Argon weighs more than potassium. Just a little bit though. But it's still before potassium, so it wouldn't make sense. So it's not the first one. And the atomic number is basically the number of protons, which is like the identifying thing for elements, right? Like something can have the same number of electrons, it can have the same number of neutrons, that's possible, but two different elements can't have the same number of protons, because they wouldn't be different elements, they would be the same element. And then these two are just periodic trends, so they're not necessarily arranged in that order. Like, if you didn't know this, you can also look on table S. There's all of that information on the table, and you can compare them if you really wanted to. And then, which element symbol represents a metalloid? A metalloid is something that is on the staircase. So if we look, cesium is on the opposite side, and so is barium. So it would be tellurium, because this is a noble gas and not a metalloid. Which term identifies a chemical property that can be used to differentiate a sample of sodium from gold? So for this one, let's see. Since it tells you that it's a chemical property, you can go reactivity like pretty much right off the bat, because density, this is physical. And then it's not necessarily a property, because temperature, anyways. But all you need to know is that if it asks for chemical property, if reactivity is an option, then it's pretty much the answer, like 9 out of 10 times. Which term identifies the type of matter that is composed of 2 or more different elements chemically combined in a fixed ratio? Not a solution, because a solution can be different concentrations. 2 or more different elements chemically combined, so it's neither of these. And like the fact that it tells you it's a fixed ratio, just based off of that, you can pick a compound, because that's what compounds are: elements, like 2 or more elements in a fixed ratio. The coefficients in a balanced equation represent this one is this. I think this is pretty straightforward. It can be the atomic numbers of each of the elements in the reaction. That just doesn't really make sense. Like, yeah. Mass numbers of the products and reactants, mass ratios, and mole ratios. Okay, so like chemical reactions, the basis of chemical reactions is stoichiometry, right? And stoichiometry is like based off of moles and ratios. So for this one, you can pretty easily determine that the coefficients represent mole ratios and not mass ratios, because this wouldn't make sense. Can you imagine, like, I don't know, hydrogen and sodium? Like, about 1 mole of hydrogen is about like 2-ish grams roughly, and then for sodium, 2 moles of sodium would be like about 46 grams. So that doesn't really make sense. Yeah. Given the equation representing a reaction, which statement describes? Okay, so it's this plus this, and it's making this. This is a synthesis reaction, which means that you're forming bonds, because to synthesize means to make, right? Making is forming, so you're forming bonds. And break, absorb, form, release. This is the mnemonic. Barf. Oh, this looks like an I. Which term represents a property used to determine the degree of polarity in the bond between 2 atoms? Okay, polarity, this is electronegativity. You compare electronegativities to determine whether a bond is like ionic or covalent, right? So that tells you how polar it is. Like, there are non-polar. Difference in electronegativity is, This autocorrect is so bad. This is even worse than my handwriting. Polarity. The difference in electronegativity is like 0 to 0.5. This is for nonpolar bonds. Polar, it's like to 1.5-ish, I think. Oh my gosh. Why is autocorrect like this? Okay. Conductivity, this doesn't make sense. Joule and Pascal, this is for energy, this is for pressure. So, and none of the other ones are for polarity. Which sample of matter has proportions of components that can be varied? Proportions of components that can be varied? Oh, okay. So it would be number 4, because this is a compound. You can't have any other ratio between nitrogen and hydrogen, because then it wouldn't be ammonia. And then solid iodine, you also can't have varied proportions of iodine, because then again it would be like an iodide ion or a triiodide ion, and it wouldn't be like iodine. Same thing with gaseous iodine. So since aqueous ammonia is like a solution, you can have concentrated aqueous ammonia or you can have diluted aqueous ammonia. It depends on how much solute you're putting in, right? Like if you think about molarity, it's moles over liters of solvent. So you can have varied proportions. You can put a lot of ammonia in a little bit of water, or you can put a little bit of ammonia in whatever the solvent is. Which term identifies a form of energy? This one will be 4. Because this is pressure. And then this is a unit for concentration. This is heat transfer. And electromagnetic energy would be the one that makes the most sense. 14. According to the kinetic molecular theory, which statement describes the particles of an ideal gas? So there shouldn't be forces of attraction between ideal gas, because then their motion wouldn't be random and straight line. And Regents geometric pattern. Yeah, random constant straight line motion is for ideal gases. And then the last one obviously is not right, because in theory, it's supposed to be a complete transfer of energy when they collide and no loss. So there's that. A reaction most likely occurs when particles collide with proper energy and orientation. This is muscle memory at this point, just saying this phrase. At STP, 2 liters of nitrogen and 2 liters of oxygen have the same, so you have 2 liters of both. And at the same pressure, 22.4 liters is 1 mole. So if they have the same volume, they have the same number of moles of gas. When you have the same number of moles of gas, you have the same number of molecules, because 1 mole is 6.02 times 10 to the 23rd molecules. Which phrase describes a factor that determines the physical state of a molecular substance? The physical state. Oh, B. Like, it's the arrangement of the molecules that matters, because if you think of just like the most common example, graphite and diamonds, they're different. The difference in the arrangement and their structure is the reason behind like the difference in appearance. right? Fundamentally, diamonds and graphite, same stuff. They're both carbon, but it's just a different arrangement of carbon molecules causes the difference in appearance between graphite and diamond. So a different arrangement of the molecules would determine the physical state of that substance. Which combination of reactants will result in the fastest rate of reaction of a 1 gram sample of zinc and 30 ml? So you want powder, because to increase surface area, right? Increasing surface area increases the rate of reaction, and you want a more concentrated solution if possible, because the likelihood of a collision with proper orientation increases as you increase the concentration of the reactant and you increase the surface area of the reactant by powdering it. So there's that. Which term represents the energy absorbed or released during a chemical change? Heat of reaction. Heat of fusion, this is for melting. And then heat of vaporization is for evaporation. Heat capacity is how much energy is needed to change a substance. By 1 degree Celsius. So that also doesn't make sense. Heat of reaction is your delta H, which is the energy that is absorbed or released during a chemical reaction. In terms of energy change and disorder, systems in nature, lower energy and higher entropy. This is also like just memorized in my head now, but conceptually, in terms of disorder, like my teachers always taught this metaphor, right, of entropy being your room. In the beginning of the week, you may or may not clean your room. If you do, that's great, but over time, as you get busier throughout the week, your room gets more chaotic, right? Like my desk, right after I clean it, it's pretty good. But then after a few days, it's like there's papers everywhere. There's pens on the ground. There's stuff all over the place. So over time, systems tend towards greater disorder, greater entropy. And then in terms of lower energy, I like to think of it like, say you have two reactions. This is the potential diagram for one of them, potential energy diagram. And then this is the potential energy diagram for the other. They're both exothermic, but which reaction would you consider more spontaneous? Probably this one, right? Because of the fact that, look, the energy here, the activation energy is very little. So it only needs to overcome a very low energy barrier in order for the reaction to happen. So, yeah. And, I mean, definitely you don't need to do this, like, quantitatively in Regents Chem, but if you want to know, delta G equals delta H minus T delta S. This is just a equation from the AP Chem reference tables. Delta G is spontaneity, delta H is energy, T is temperature, and delta S is entropy. So when you have negative delta H and positive delta S, you always have a spontaneous reaction despite temperature conditions. So that's essentially what the answer to the question is, like negative enthalpy meaning lower energy, and positive entropy meaning greater disorder. What molecule of which straight chain hydrocarbon contains 9? So here you just have to look at their prefixes. This is 4, 6, 3, and 9. So this one would be number 3. 22, which compound is an unsaturated? Okay, so just based off of unsaturated, we know that this can't be an alkane. so it can't be octane. And out of the other ones, we can determine which one is the unsaturated hydrocarbon, because we know that butane is the only other hydrocarbon other than octane, but that's saturated because it's a alkane and not an alkene or an alkyne. These two are not hydrocarbons because this heptanol contains a alcohol functional group, and ethanol has an aldehyde functional group, right? It has this terminal hydrogen and this. So it has that going, so the oxygen here. So yeah, number 2 would be the only answer that would make sense. Next one, what is the number of electrons shared between the carbon atoms in an ethene molecule? So there's 2 carbons, so the double bond has to be between them. So if there's a double bond, one bond is 2 electrons, 2 bonds is 4 electrons. Which 2 terms represent types of organic reactions? This one, yeah, I'm pretty sure this one you just have to memorize. For this one, though, it's substitution and polymerization. Vaporization is not a organic reaction. This is a phase change. And so is solidification. I guess that's just freezing. Oh, maybe you don't have to memorize this. This is common sense. Evaporation. So substitution is like when, maybe you have something like this plus, I don't know, fluorine maybe, and then you react and you get an F now and a hydrofluoric acid. And then polymerization is when a lot of organic monomers, they link together to form a chain, right? And that is called a polymer because it has multiple monomers. In an operating electrolytic cell, oxidation occurs at the anode. Starts at the anode, electrons are lost there. Or you can, anox, red cat. Anode oxidation, reduction, cathode. An Arrhenius base yields which negative ions? Hydroxide. Hydronium is not negative. That's for sure. Hydronium is positive. Ammonium is positive. And peroxide is just, that doesn't make sense because in an Arrhenius base, it doesn't yield peroxide. Acids and bases, it's either hydronium or hydroxide. So it's not these two either. Which change in the concentration of hydronium ions result in a decrease of 1 unit of the pH value for an aqueous solution? So 1 unit in the pH value is tenfold decrease. Decrease in tenfold increase, Because pH as you go down is more acidic. And pH, if you need to quantitatively calculate the pH of a solution, the formula is negative log concentration of hydronium. So it's an inverse relationship, right? As pH goes down, the concentration of hydronium goes up. So when you're decreasing in pH unit, the concentration of hydronium ions actually goes up, right? So obviously you get rid of 1 and 2. And then the fact that pH, 1 unit of pH is 10 times the concentration of H+, I think that you just have to know. Based on table N, which phrases term describes the half-lives and the decay modes of uranium? Same decay mode, they're all alpha decay. Different half-lives, I'm pretty sure though. Okay, so this would be 4. Yeah, I don't know if it's possible to have two different radioisotopes have the same half-life. That sounds pretty interesting. I'll maybe search that up afterwards. I feel like that's really unlikely. I don't think that's possible for two different radioisotopes to have the same half-life. Nuclear fission reaction results in the net conversion of mass to energy. Yeah, mass to energy. Yeah, because nuclear reactions are like very well known for producing like a heck ton of energy. Like if you compare how much the amount of reactants that you have to normal chemical reactions, you would find that nuclear reactions produce a significant, very, very, very significantly different amounts of energy compared to typical chemical reactions. What is the risk associated with the production of energy in a nuclear plant? Yeah, I don't know what to say. This is not really a chemistry problem, I think. This is just I think you guys got this. The diagram below, blah, 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 two charged plates. Okay, so it's going towards the positively charged plate. So this thing is negatively charged. It's not a positron, not a proton. Neutron doesn't have charge. It's got to be an electron. Which electron configuration represents the electrons in the neon atom in an excited state? So neon, it would have 3 shells now. This one. This would be for fluorine. This is the ground state. This is the ground state of fluorine. So there's that. Element X reacts with chlorine to form the compound XCl3. In which group on the periodic table is X located? Okay, I guess the oxidation number, the most common oxidation state for chlorine is just -1. So the X we know has to be +3. Group 1 and 2, group 1 is +1, group 2 is +2, group 18 is noble gas. So your only option here really is just group 13. And also, I guess the Regents reference table has the oxidation states, so you could have just looked at that too. Whoops. What is the number of moles of calcium oxide in a 238 gram sample of CaO? I need my calculator for this. Okay, 238 grams over 1. I got 4.2424 repeating. So I guess if you round, it's number 2. What is the molarity of an aqueous solution that contains blah blah blah? Okay, so molarity equals moles over liters. This one I got 0.17. Which statement describes the freezing point of a solution prepared by dissolving ammonium chloride in water at 25 degrees Celsius? So when you dissolve a solute into a solution, the freezing point decreases, right? So it would have, a freezing point lower than 0 degrees. And why would the freezing point be 25? That's just silly. This is like pure water, right? And since we know that they're dissolving solute, the ammonium chloride, into it, it's changing the freezing point. At which temperature and pressure will a sample of real gas behave most like an ideal? Okay, so you want, first, I guess I can just say you want like high temperature and you want low pressure for gas to behave ideally. But this is the mnemonic: pressure, low, ideal, gas, high, temp. So what would the answer be here? It would be this one, because this one is the highest temperature and the lowest pressure. In a sealed, rigid container with a movable piston, a sample of H2 gas occupies 30 liters at blah 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 blah. Sorry, that was not very nice. I don't want to read all that. The formula you would use is on the back, the combined gas law. I hate doing these. So much writing. Which statement explains why a catalyzed reaction occurs at a faster rate? So, let's draw another potential energy diagram. So this is your normal reaction pathway. The dot will represent the catalyzed reaction. So the reason why catalysts increase the rate of reaction is because it provides an alternative pathway, right, for the reactants to take that slower activation energy. So it's easier for the reaction particles to have enough energy to overcome that barrier and turn into products. So your answer here, your answer choice, you can just pick one, because it says that catalyst prevents a different reaction pathway, lower activation energy. At standard pressure, which 10-gram sample of nitrogen has the greatest entropy? So since this is all nitrogen, you would just pick the one that is at the highest temperature, because at high temperatures, particles move at a faster speed, right? Because you're at a higher temperature, you have higher average kinetic energy, so the particles are moving like crazy. And if you have particles that are moving faster, naturally there's more disorder, because the particles are moving more randomly and they're moving like very quickly. So, yeah. Functional groups. Oops. So this is an organic acid, COOH. And then this is an H2. So this is not reading this. Amine and organic acid. Number 2. Given the equation representing a reaction when the iron atoms lose 2 moles of electrons, the copper ions in CuCl2, they would also gain 2 moles of electrons, because law of conservation of charge, right? Conservation of charge. You gain what you lose in a reaction. What is the change in oxidation state for aluminum in this reaction? So it goes from this to +3. Sulfuric acid, H2SO4, blah 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 blah, CaSO4. Yeah, because this is a polyatomic ion, right? This is sulfate, and its charge is -2. And calcium ion's charge is +2. So they go perfectly together. There's no need to change anything. And this is just weird. Why would it be SO3? Blah, 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 blah. So this is a transmutation because this is like a nuclear reaction, right? One of the nuclear reactions. If you look at that, this is not synthesis because it's not two things coming together to combine into one. And this is not an organic reaction, so this is not esterification or substitution because 2 and 3 are both organic reactions. 46 asks, which equation represents nuclear fission? So fission means one big thing and it's breaking into smaller things because it's fizzing. Yeah, it's like fizzing away, you know, like when the bubbles in your soda fizz away. But anyways, it's not this because those are just nuclear reactions. I mean, those are just normal reactions. It would be this one because it's breaking into two more stable radioisotopes. That's what it's doing. It's breaking into 2 more stable and like smaller radioisotopes. So that would be nuclear fission because it's a big thing fizzing into a smaller thing. Oh, wait, yeah. It's combining into, okay. I was like, what? Okay. This one would be synthesis because it's 2 smaller things combining into this, right? It's elements combining with elements to form a compound. Like if you think I should probably write the phases. But yeah, I feel like this gives you a more like a clearer view because the way they did it here is kind of trippy, not gonna lie. This like makes it clear that this is a synthesis reaction because it's 2 things combine to 1. The diagram below represents a laboratory process that is used to separate a mixture from 2 different liquids. This is distillation. Yeah. Usually when they tell you 2 different liquids, you can pretty much know that that's distillation because you can't really filter 2 different liquids, right? If they're both liquids, then you're not gonna really do anything filtering them. Titration is not. I don't think titration is a way to separate mixtures. It's more for quantitative analysis, I think, when you have to determine, like, I don't know, normal acid-base titration, you normally determine the concentration of your analyte, and if it's like a redox titration, you're determining how much of your oxidizing agent you have. And then crystallization, this is just not what it's showing, though, because you have, like, your whole setup here that's telling you a condenser, and then a hot plate, so it's boiling. It's boiling the liquid in here, and this is collecting the so the stuff that evaporates first, and then the liquid here then gets collected into a beaker. 49. Given the equation representing a system at equilibrium, which statement describes the base in the forward reaction? Okay, so first you should identify your conjugate pairs. Base acid, conjugate base, and conjugate acid and conjugate base. So the base in the forward reaction would be the CO3. Because it accepts. And then 4 would be incorrect because only acids donate. They do not accept. And this was asking for a base. So wouldn't be any of these. What is the half-life of this isotope? So originally you started at 20. 20 divided by 2 is 10. So we have to look at where it's 10. And rough estimate, but I think that's 8 days. Wait, actually this is not an estimate. This is going up by 2s. Sorry, this is 8 days. That's the half-life because in 8 days it went down by half. And then if you look at the next one, this is at 16. So it went down by another half. This is how you can tell. Alright, FRQ section. Based on table F, identify one positive ion that forms an insoluble. Okay, so with the halides, you can say you have a few options here. I think it's silver. You can also do lead, or you can do mercury. Stop moving. Okay. State the number of valence electrons in an atom of M in the ground state. Okay. So has 33. This would be ours. So 5. I'm kind of lazy, so I don't want to write out the whole thing. Judging by the fact that it has 33 protons, I just said that this has got to be arsenic. So I looked on the reference table for the electron configuration of arsenic, and the number of valence electrons is 5. That's the last number, right? So it's a quicker way, instead of writing out the whole thing, compare the mass of a proton in an atom of R to the mass of an electron in an atom of R. So protons are way more massive than electrons. So you can just say that proton has greater mass. Write the 2 letters from this table that represent atoms that are isotopes of the same element. M and Q, because oh, should I write MQ or MNQ? Because they have the same number of protons, but a different number of neutrons. So when that happens, that's how you know you have an isotope. Or you have 2 isotopes. Compare the radius of a potassium ion to the radius of a potassium atom. So what potassium does is that as a metal, it loses electrons as an ion. So when you lose electrons, you become smaller, right? Because being an alkali metal, if potassium loses 1 electron, it will only have, it just loses its 4s orbital. It loses its 4th shell, so its size is smaller, so you would just say that the K atom is bigger. Identify the noble gas that has atoms in the ground state with the same electron configuration as a potassium ion in the ground state. So this one here, it would just be argon, because potassium is element number 19, right? And if it loses one, it becomes 18, and argon is element 18. So yeah, and you can also just like look back and count in your periodic table, because you have that available to you. It's very, very handy. Okay, so bromine typically has 7, but since it's a bromide, it would have 8. So you can just draw like this. You do need to include the brackets in the sign though, because it's an ion. Identify the type of bonding in a sample of solid potassium. So since potassium is a metal, it would have metallic bonding. Yeah, I think that's pretty self-explanatory. Metallic is for just pure metals, and if you have ionic, that would mean like potassium with something like chlorine. If you have, well, you can't have a covalent when you have potassium, because potassium is a metal and covalent is 2 nonmetals. So yeah. State in terms of valence electrons why the bonds in a molecule of hydrogen sulfide are covalent. Oh. Okay. The bond between because in ionic bonds the electrons are transferred, and in covalent bonds the electrons are shared, because like when you think of the prefix co, it should, like something along the lines of maybe sharing should come to mind, because you have words like co-workers, you have cooperation, which is like working together. So yeah, since it's covalent, the electrons are shared, so you can just say that the bonds in a molecule of hydrogen sulfide are covalent because the electrons are shared, or something along those lines. And explain in terms of charge distribution why the molecule of H2S is polar. So this is your H2S, right? And if we look at the electronegativities, H is 2.2 while S is 2.6. So the sulfur in this case will be partially negative while the hydrogens are partially positive. And if you look at the charge distribution, that's asymmetrical, right? So you would get that. You can say asymmetrical distribution of charge. Compare the rate of the forward reaction to the rate of the reverse reaction in the system. So it says equilibrium system in a sealed rigid container represented. Okay, so if it tells you that the system is at equilibrium, that means this forward reaction and the reverse reaction, their rates are the same, because otherwise that's not equilibrium. So you can just write same, I'm assuming. Or if you want to be safe, you can write the rate of the forward reaction is equal to the rate of the reverse reaction. But I'm too lazy for that. State the effect on the concentration of iodine gas when hydrogen gas is added to this equilibrium system. So when you add hydrogen gas to this equilibrium system, it actually shifts the reaction, because this now becomes and it gets shifted to the right, to favor the production of the products. So what happens to the concentration, or the partial pressure, concentration, partial pressure, same thing, basically. Not really, but the idea is like the same. Anyways, what happens to the iodine is that it decreases as a result of equilibrium shifted right. So this feels so wrong. Why would you use concentration, not partial pressure? Draw a potential energy diagram for the four react. I don't have the answer booklet, so I'm assuming it's just like this. And the bottom says reaction or time, and the key here is heat is a reactant, so that means this is endothermic. What you can draw here will be like this, where the products are higher up than the reactants. Since it's endothermic, it's absorbing more energy as the reaction proceeds. So in the end, your energy for your products would be greater than your energy for your reactants. Complete the nuclear equation for the decay of radon by writing a notation for the missing product. I don't know what the missing product is going to be, so I'll just write the whole thing out. Radon, decay, alpha decay. Yeah, so this is the whole reaction, and whichever one the answer booklet is missing will be your answer. I'm assuming probably this one, because I don't think they would just ask you to write like an alpha particle. That seems silly. Determine the time required for a sample of radon-222 to decay until only 1/4 of the original sample remains unchanged. So this is after 2 half-lives. 1 half-life of radon is 2 half-lives is that times 2. I'm assuming they're not going to ask for sig figs, but it doesn't really matter. Identify the element classification of these 3 elements: chlorine, phosphorus, and sulfur. They're all nonmetals because they're on the right side of the periodic table, and they're beyond the staircase, if you will. Determine the mass number of an atom of sulfur that contains 18 neutrons. So sulfur is element number 16? Yep, 16. 16 plus 18, that would be 34. That would be your mass number. State the trend in atomic radius as these three period 3 elements on the periodic table are considered in order of increasing atomic number. They're all in period 3. Perfect. So the atomic radius decreases. The reason for that is because going from left to right, or increasing atomic number, means that you have more protons, and what happens when you have more protons is that you have a bigger nucleus, which according to this equation, which would mean that you have a stronger force of attraction. So basically a bigger nucleus pulls the electron shells tighter, and that means that the radius of these atoms are decreasing, going from left to right, or increasing atomic number. Identify which of the 3 is a gas. Chlorine. You have your Dr. Brinkelhoff as your mnemonic. Bromine, iodine, nitrogen, chlorine, oxygen, hydrogen, and fluorine. show numerical setup. For calculating the gram formula mass of silicon dioxide. Okay. So I guess you just do, like, silicon is 28.0855 plus 2 times 15.93914. This is your numerical setup. Write chemical name for the product CO in the equation. So this one would be carbon monoxide. Determine number of moles that are required to produce 4 moles of silicon carbide. So it's 3 to 1. So if you want 4 moles of silicon carbide, you need 12 moles of C. Okay. Identify the physical change that takes place during interval BC of the heating curve. Melting takes place. Melting. The reason for that is, like, here you start in the negatives, that means you're a solid, and then A to B you see the increase in temperature, which means that it's just the sample is getting warmer, it's gaining kinetic energy, and then when the graph shows like a zero slope, that means that the potential energy is increasing and it's going from a solid to a liquid, and the temperature is not changing during that phase change itself. State what happens to the average kinetic energy of the molecules in H2O during interval CD. So average kinetic energy here over this interval is increasing because it's like temperature, essentially. Average kinetic energy is basically temperature. My chair creaks so loudly. And at point B it's 0, but at point D is 10. So this is increasing from 0 to, 100. 0 to 10, oh my gosh. Determine quantity of heat absorbed when 120 grams of sample water boils away completely at its boiling point. So this one you would just use the heat of evaporate. 220, let me see. This is on the reference table, which is really nice because I wouldn't remember this. Oh, I forgot to write the formula down, sorry. This is Q equals MHV because it's boiling point and not melting point, so you need the heat of vaporization. And 120 grams times, I got 271,200. Write the general formula of the homologous series to which these compounds belong. Okay, so alkanes, they belong to alkanes, which the formula I think is this. I don't want to flip open the reference table again, it's so much work. Go. State in terms of strength of intermolecular forces why the boiling point of dimethylpropane is lower than the boiling point of pentane. Pentane is higher because it has stronger intermolecular forces. So, I guess what, like, the thing behind it is that if you have stronger intermolecular forces, there's like, it's harder for the substance in the liquid phase to overcome the energy barrier and reach the gaseous phase, right? Because there are things, essentially, the forces are holding them back. The forces are so strong, they're resisting the boiling, if you will. So, since the IFAs between the pentane, that stopped recording for a second. Anyways, as I was saying, 2 branches, 1 carbon each, so you would have something like C bar. Something like this. So, wait, 1 line too much. That's really ugly, but it's fine. State the form of energy is converted to chemical energy is converted to electrical energy. I just said it's just so natural after doing a lot of these. State in terms of electrons, what direction, blah 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 blah. So as you can see here, this is being reduced. Zinc is the cathode. I'm a little sleep deprived. This is oxidized because it's going from 0 to +2. So this is the anode. And as we know from anox red cat, or just because, the electrons flow from anode to cathode. So you can say like Mg to zinc, or you can write the whole thing out. It doesn't really matter. Identify the positive ion present in the HCl, in aqueous HCl. That would be hydronium. Because HCl, it's a strong acid. It dissociates completely, and so this is ionizes completely. So this is the equation. Right. Since the chlorine, it's a halogen, it pretty much, its most common oxidation state is going to be -1. And hydrogen, it's pretty special, right? Last video, pretty special. Anyways, hydrogen, it can be both the positive ion, or it can be the negative ion. It can be the cation or the anion in a compound. But in this case, this is the hydrogen is our positive ion, so it's the hydronium. Well, I didn't write HT, I wrote H+. Or you can say H3O+, hydronium ion, or whatever. Determine concentration of HCl using titration data. So, A, V, A, M, B, V, B. So if you plug that into your calculator, I got 0.3. 0.3 molar. State the color of bromocresol green if it's added to a sample of the sodium hydroxide solution. So sodium hydroxide is one of the most common bases we deal with, right? So bromocresol green, it turns blue in base, like in basic conditions. Any pH over 5.4. So that's definitely blue in a base. Because typically, like, the pH of strong bases, even if it's not super concentrated, is like above 10. state in terms of ions why a sample of the 0.1 molar sodium hydroxide is a good conductor of electricity. So conductors, they have mobile ions, and since sodium hydroxide is a strong base, it completely dissociates into sodium ions and hydroxide ions. So you can say the solution has ions, and that's why it's a good conductor of electricity. Okay, so that was pretty fun, very interesting, and good luck studying. Good luck on your test and have fun studying.